Hello everyone. Today's topic is the ideal gas law. So the ideal gas law combines the four main variables we've discussed previously: pressure, volume, temperature, and number of moles. So this is the formula for the ideal gas law. Hopefully we're familiar with most of these variables. P represents pressure, V represents volume, N represents the number of moles, R is new, we'll get to that in a moment, and T is temperature, which again should always be in Kelvin. So R is the universal gas constant. It has different values depending on which pressure unit you're using. So for this class, we're going to be using ATM for most of our problems. And for ATM, the R value is 0.082. If you're in doubt about what value or what pressure unit the R value is for, you can always just look at the units for the R value itself. You'll see here that ATM is in the unit. That means that the pressure, or the R value here, is specifically for pressure in ATM. So let's try an example. Again, our formula is P times V equals N times R times T. So if I have 4 moles of a gas at a pressure of 5.6 atm and a volume of 12 liters, what is the temperature? So first let's identify our variables. Pressure, or P, is 5.6 atm. Volume, or V, is 12 liters. The number of moles, or N, is 4 moles. R, since we are working with ATM as our pressure, is 0.082. And T, or temperature, is our unknown. That's what we're trying to solve for. So, if we plug all of these into our equation, we have 5.6 for our P value times 12 for our V value is equal to 4 moles times 0.082, which is our R value, times T, or our temperature in Kelvin, which is our unknown. We then divide by 4 and by 0.082. These cancel, but we need to do it to both sides. And we end up getting 205 Kelvin is our T value. So that's it. It's pretty similar to our other formulas we've been working with, except now we have our R that we need to take into account, and it also takes into account the number of moles of the gas that we are working with. If you have any questions, feel free to ask. Thank you.